All right, guys, we're on to the last one, dilations, and then the last one up is compositions, but in terms of the big four, this is the last one. So let's get started. So when we talk about dilations, we talk about things dilating. We're talking about things getting bigger or smaller. Thinking about like your eye pupils, water. Water does dilate. When you freeze it, it expands. Okay, things like this do not. They have no change in their orientation. Water still stays as water. The ions that you know of, the Mickey Mouse ears, one oxygen, two hydrogen, will currently stay that way even if it gets bigger or smaller. It'll always be that way. Same for eyeballs. They don't actually change the orientation. They go from this to this, this to this. All right, so let's go ahead and take a look at an example. Okay, so let's say I have a pre-image that is at -2, 1. Let's say it's at -1, 2, and at 1, 1. Okay. So we have A, B, and C. Okay. So our pre-image is A is -2, -1. B is -1, 2, and C is 1, 1. Okay? So from there, we can then say, all right, well, what's our image is going to be? Well, let's just say that I get A prime, I'm going to get -4, -2. B prime, I get -2, 4. And C prime, I get 2, 2. Okay, so already those numbers, look, if these starting to look a little interesting to you in terms of scaling, then you're in the right idea. So then we're going to end up at over 2, 1, 2, or over 4, 1, 2, 3, 4, down 2. Okay. Then we're going to go over 2, up 2. And then we're going to go back 2, up 4. 1, 2, 3, 4. So here is our new triangle. Now, when you do dilations, it's okay if the shape goes and cuts through the other one. Cuts through the other one? Yeah, cuts through the other one. Okay, or crosses it, or layers on top of it, lays on top of it. Layers works too. It's perfectly fine. It is perfectly fine. Okay. So B prime, C prime, and A prime. So this guy obviously got bigger, okay? But what is our rule? What is our rule that is telling us all of this? Okay, well, our rule is we enlarged by 2. Okay, 2 times -2 is -4, -1, -2. So you can see how this guy got bigger, okay? And there is a specific way we write these rules, okay? So when we write these rules, and we'll address that here in a moment, but when we write these rules, I'm just checking something, okay? We would obviously write these as scale factors. So let's take a look at how we do that. So let's go back over to here, the algebra side of things, okay? So what we do is we have our original, I just want to underline these. This is from a couple videos ago, if you guys remember. And I like having consistency in my notes. So, original, right? We have the original, and we're trying to get the rule, okay? And the original states the following, okay? And of course, our rule okay, there we go. So the original is going to be xy, right? It hasn't changed at all. in order to get what we need, the rule is this. Kx, ky. Big old star down here you need to pay attention to. K is the same for both x and y values. Okay? Otherwise, it wouldn't be called a scale factor. Okay? So that's very important that you know that. All right? Like super duper important. All right? Now, going up to descriptions. Do this in purple. Okay, this is relatively one of the shorter ones. We're going to multiply scale factor k to all points of coordinates. Okay. The asterisk, not a star, the size transformation of magnitude k. And what that basically is saying is it's in a formal way stating the mathematics behind this statement. This is just like the formal version, which is why it's an asterisk and not a star. It's not important you remember this, but it's fun to know. Okay, and finally, definitions, right? Definitions. So for this one, again, don't overthink it. We shrink / enlarge. Okay. Now, here are the big ones. There's a change in position. There's no change in orientation. And finally, it is not isometric. Okay? There are 2 stars to keep in mind. Okay, that this is another one where it's going to be centered at a point, that point being 0, 0. Okay. And the scale factor k. All right, this is important to note. If k is bigger than 1, it enlarges. If 0 is less than k is less than 1, it gets smaller. Okay, or shrinks. All right, sorry about the microphone. And that's it. That is all you need to know for dilations. Congratulations, we are done with all the main 4 versions of transformations. Now we'll do some few examples in the next video on dilations, and then our last one is compositions. And just start thinking about what you think when you hear that word compositions. All right, you guys have